Okay, let's go over Dalton's law of partial pressures. At a constant volume and temperature in a mixture of gases, the total pressure is equal to the sum of the partial pressures of each gas. So Dalton's law is really straightforward. The total pressure of a mixture of gases is equal to the partial pressure of each of the gas that's in that mixture. So it doesn't matter how many are in there, we simply add them up. So we like Dalton's because it's very simple. Alright, so let's look at an example problem, 413. Air contains oxygen, nitrogen, carbon dioxide, and trace amounts of other gases. What is the partial pressure of oxygen at 101.3 kilopascals of total pressure? So this is our total pressure. I'm going to go ahead and start listing my givens over here since it's so crowded. My total pressure is 101.3 kilopascals. If the partial pressure of nitrogen, carbon dioxide, and other gases are 79.1 kilopascals, 0.040 kilopascals, and 0.94 kilopascals, respectively, that means this is nitrogen, this is carbon dioxide, and this is all the other gases, the trace gases. Let's list them then. We've got P, O2 is what we're looking for. The pressure of nitrogen, PN2, is 79.10 kilopascals. The pressure of carbon dioxide, 0.04 kilopascals. And of course all of the other trace gases are lumped into this one, 0.94 kilopascals. And so we're going to be using Dalton's, which is P sub T. The total pressure is equal to the pressure of oxygen plus the pressure of nitrogen plus the pressure of carbon dioxide, the O2, plus the pressure of all the other trace gases that are in there. And we're going to rearrange to find O2. And to do that, we're just going to subtract these three gases from both sides of the equation. So we end up with PO2 is equal to the total pressure minus the pressure of nitrogen minus the pressure of carbon dioxide minus the pressure of the trace gases. And so we're just going to plug these in, solve for the partial pressure of oxygen. And so the total pressure is actually atmospheric pressure, 101.3 kilopascals, minus nitrogen, which is 79.1 kilopascals, minus our carbon dioxide, small amount there, kilopascals, and our trace gas, 0.94 kilopascals. All right. And so we end up with the partial pressure of oxygen, 101.3 minus 79.1 minus our 0.04 minus 0.94. And so we get one decimal place is the least number in this group. And so since this is addition and subtraction, we go by the number of decimal places. So we're going to have to stop at one decimal place. So we have 21.2, and our units, of course, are kilopascals. So let's try a practice problem now. 414. Determine the total pressure of a gas mixture that contains oxygen, nitrogen, and helium if the partial pressures of the gases are as follows. So our pressure of oxygen is 20 kilopascals, our pressure of nitrogen is 46.7 kilopascals, and helium is 26.7. So our total pressure is this time what we're looking for, and we have our PO2, 20 kilopascals, our PN2 is 46.7 kilopascals, and our PHE, helium, is 26.7 kilopascals. And of course our formula, PT is equal to PO2 plus PN2 plus PHE, and we're just going to add them all up. Gotta like Dalton's. Kilopascals and 26.7 kilopascals. Let's see if we can simply add these up. 20 plus 46.7 plus 26.7 gives us a total pressure of 93.4 kilopascals. So that's our total pressure for this gas mixture. Okay, so let's try another one. A gas mixture containing oxygen, nitrogen, and carbon dioxide has a total pressure of, so there's our PT, of 32.9 kilopascals, if PO2 is equal to 6.6 kilopascals, PN2 is equal to 23.0 kilopascals. What is PCO2? Alright, so we've got our givens right here. They're already listed, so I'm not going to list them again. We don't have much room anyway. Okay, well, no, might as well just do it here. So we've got our equation. We're going to simply be adding up these. Actually, no, we've got to find PCO2. So we're going to have PO2 plus PN2 plus PCO2 is our original equation. But we have to rearrange it to solve for PCO2. So our PCO2 is going to be isolated, and we're going to subtract PO2 and PN2 from PT. PT minus PO2 minus PN2. Just put in our givens now. The total pressure is 32.9 kilopascals. And we're going to subtract the pressure of oxygen, 6.6 kilopascals. And we're going to subtract the partial pressure of nitrogen, which is 23 kilopascals. And so we end up with 32.9 minus 6.6 minus 23. And we end up with 3.3 kilopascals. So that's pretty straightforward. We like Dalton's.